All right, let's try this again. Okay, so what I'm going to do now is I'm going to do a couple of things. One is we're going to look at on the whiteboard here a couple of examples. Something I wanted to point out about how this whole class, abstract class, and stuff like that works. And then the other things we'll look at some examples, and then that will be it for today. Okay. All right. So let me go ahead and share. This. Okay. Okay. All right. So one of the things we talked about here was this whole deal where if you had a class like geometric object, right, and we created from it maybe a circle, maybe a rectangle, that kind of stuff, right? Okay, so I said, let's say that this is an abstract class, okay? And I said you could create, so let's say you had a geometric object G equals new, and I said you cannot put geometric object here. You cannot create a new geometric object type, okay? So you can't do that. Okay, but what you can do is you could create a new circle, radius 5, for example, or you could have created a new rectangle with 3, 2, a 3 by 2 rectangle, for example. Those are possibilities. So here's why. Here's part of why. Okay. Remember when? No, not that. I don't know what's going on. I don't know what's going on. Okay. So remember that what happens out here in memory, when this happens, right? That's what I wanted to do. I wanted to change colors. Okay. Remember that what happens is we out here in memory. Right? And when we do this, we create this circle object out here in this memory location, right? Now, somewhere else in memory, we've got this G variable that has to be a geometric object. And all we really do is we just say, okay, that's the address. Look there. When you want to find my geometric object, look, go there, right? Or when we created this rectangle. Okay, this rectangle here. All right, and we could say, don't really look there anymore. Now we're going to look here. All right. What we're doing is we're saying the memory location can point to anything that's a child of geometric object. Okay, so it can point to a circle, it could point to a rectangle, it could point to a square, it could point to a triangle, it can point to anything that we create that's a child of geometric object. Okay, but what we can't do, we cannot create here we cannot create in memory something that has a type of geometric object. The only things that we can create in memory out here, the only things that we can create objects of are things that actually are concrete. They have no abstract methods, right? They are not abstract themselves. Mm-hmm. And so you might be like, well, why'd they even create this whole abstract method stuff in the first place? It makes no sense. It's so silly. Like, why do we even have that? The reason why is one of the things I said towards the very beginning of the previous video's lecture is what we're trying to do is we want to define something that's kind of a generic type that's got a lot of things in common, but we don't want anybody to create something of that type. So we want to have a person class that there's some things in common, but no person that we create can be just a person. They all have to be something else. They all have to be a student or a teacher or something like that. Okay, a geometric object, a shape. And so we call it a shape. We cannot have a general shape because what would happen? How would you define what the area of a shape is? Well, it depends on, is it a circle? Is it a rectangle? All right. We want to be able to give a concrete answer to what is the area of an object, right? What is the perimeter, right? We want to give concrete answers to those questions. We can't do that with just a geometric object on its own. Okay. All right. So I hope that clears up some stuff there. Okay. So now what we'll do is we'll look at some specific examples. Let me come back off of here. Okay. All right. Okay, so let me go make it bigger. All right. Okay, so let's take a couple of examples here. So we have this whole, remember, geometric object. We talked about this. So the way that we define an abstract class is we say public abstract class. So now the public, remember the public keyword tells me that that is the file name for this Java file, right? You don't have to have the public keyword. You can have an abstract class for some subclass, for some other class inside of this file, okay? But the abstract keyword comes before the class. So we're saying abstract class and its name, okay? Here are some attributes that all geometric objects are going to have, all right? Some constructors, some different methods. They have an abstract method for get area. Why? Because we don't want to define the get area method in the geometric object class. We want the individual subclasses to define their own get area. We want the circle to be able to say, this is how I'm going to calculate my area. We want the rectangle to be able to say, this is how to calculate my area, and so forth. Okay. Pull up the rectangle too. Just okay. And so then when we create a circle, we say, just like we talked about last time with inheritance, class circle extends our geometric object. Now what that means is that, so we have the constructor, same as before, the radius and the set. Notice we have to override the get area method. Okay, so we have to tell it how to get the area. We have to override the get parameter method. All right. So if we were to compile this, okay, I'll make sure there were no errors. Okay, good. And if we were to compile this, good. Now, what I'm going to show you is what happened if we said, you know what? But it's not called perimeter for a circle. It's called circumference, right? So I'm going to save that. And I'm going to compile that. And I'm going to get a compiler error. Big, ugly compiler error. Circle is not abstract and does not override an abstract method called getPerimeter in geometric object. Oh. Okay. So what it's saying is you didn't override a method that existed in the abstract class that's its parent. It also says, hey, you use this override indication, this compiler directive, to say that you were overriding a method, but this method doesn't show up in the previous class. So let me show you. Let me show you another way to look at this. Another way to do this. So let's say you were to say, okay, well, fine. And what I'll do is I'll just copy. What I'll do is, if you want to be like this, you want to be like this, we'll go ahead and override the get parameter. Sure. So now I'm going to compile this. Wait. So, but I replaced the parameter method. What the compiler is saying is that you're telling me that you're overriding something, but this is not right. This method doesn't exist. This method does not exist in the parent class. So how can you override a method that doesn't exist in the parent class? This is a very useful compiler directive. This is very, very useful. That if you think that you are overriding a method from a parent class, you should put this in there so that you know whether or not you're spelling it correctly and that you're overriding the correct method. So let me show you what I mean. Let me show you what's. So now if we were to save this and compile it now, it works, right? So let's say you were to say this. Okay. Now you may think that's the same thing, but as you know, that's not the same thing. And I should get two compiler errors again. Right? It does not override method getPerimeter, and it's also saying that you're telling me you're overriding something, but what you're overriding doesn't exist in the parent class. And you can realize that, oh, and sometimes it could be stuff like if the method above is called, hard words to spell, like arithmetic, right? Arithmetic, right? Arithmetic's a hard word to spell, right? And there's other hard words to spell, but sometimes we make a typo. So one that I've seen a lot. Right? Get length might be the correct spelling, and you might accidentally type it like this. Right? And if this exists in the parent class and you put override that, you'll get a compiler error because it'll say this method does not exist in the parent class. Okay. Okay. And then rectangle also extends geometric object. So it's going to have different things. It's going to have a width and height. We are going to also override the get area method here. We're also going to override the perimeter method, the get perimeter method. So we compile it. Right. And we can test these things, right? We can test our fun methods where we can create a geometric object variable, but remember, we have to put in it a concrete thing over here. So let me show you, because we did have a constructor, right? A no argument constructor, right? Circle have any other constructors? besides the no argument? No, just the radius one. Okay. So if we compile it, I'm going to debug. Okay. So notice we can create a geometric object variable that points to a circle. We can create another geometric object variable that points to a rectangle. Okay. Do the two objects have the same area? We can do an equal area method. That's inside of here though. That's inside of the test geometric object. All right. Get area 1, get area 2. And they should not have the same area, right? Display. All right. This is I believe this is the toString method. Oh, it shows the area. Sorry, nope, that's not the toString method. It shows the area, the perimeter of each one. And notice that we could use the same method, display geometric object, for both of them. Why? Because that method, display geometric object, takes a geometric object parameter. So we don't have to make a separate display rectangle, display circle. We can say display any old geometric object. And we can pass it a circle, we can pass it a rectangle. Okay. So what would happen if we tried to create a geometric object? Yeah. So I'm going to try to create geometric object 3. New geometric object with no argument. Okay. If I try to compile this, I should get a compiler error. All right. Yep. All right. Geometric object is abstract, cannot be instantiated. I cannot create an object of type geometric object. Okay. So I can't do that. Let me try to give two that are the same. Let's see, 5, 25, math.py. Okay. That should have the same area, right? Yay, they do. They both have the same area now, right? Because I gave them the same area, 25 and pi. Right? So I have a 25 length rectangle by a pi width rectangle. So I do get the same area. All right. Okay. So those are some examples involving the circle and the rectangle. Let me get out of that. Okay. See, edible is here. What's my test edible thing? Tiger. Do I have a tiger? Okay, yeah. So I have an abstract class. Remember I said it doesn't have to be public because the public class here is the test edible. So this is a test of the edible interface. So I have an abstract class called animal that's going to have an abstract method for sound. So what does that mean? It means that every time I create a new concrete class that extends animal, I need to give it a sound. Okay. Chicken extends animal and implements edible. So chicken is a type of animal and it is an edible animal. Okay. So the edible interface, let's take a look at it. The only thing it has is an abstract method, how to eat. So what that means is that when I did this, when I said abstract class, class chicken extends animal, implements edible, immediately what my compiler will look for when it goes to try to compile this class is it's going to say, okay, I need a method called sound that returns a string. I need a method called how to eat that returns a string. So it's going to take both of those and it's going to bring them in. And it's going to say you need to create both of those. So the first thing we do, we can do either one first, doesn't matter. We're going to override the how to eat method. Chicken, fry. I don't know. I don't like fried chicken. I'm on a diet. I'm trying to lose some weight. We could grill it, or is gotta. All right, or my personal favorite. Done that. All right. So we can do, however, right? Let's go is gotta. Okay. Okay. And then we also have to override the sound method. All right. Chicken. Cock-a-doodle. That's English. That's not right. Right. All right. So now we got our chicken making the right sound. Good. Okay. All right. So then we can create a tiger class, and it extends animal. What does that mean? Our compiler only needs the sound method to be implemented, right? So we say, okay, return tiger, and a tiger goes roar. What does a tiger say in Turkish? I don't know. I don't know what a tiger says. Kaplan ne diyor? I don't know. Okay. All right. Then we have an abstract class fruit that implements edible. We could have any kind of data fields, constructors, and methods of the fruit class. Now, because fruit implements edible, it means that all of its children are going to need to have implementations for the how to eat method. So apple extends fruit. Now, fruit didn't add any new abstract methods in it the way we've done it currently, but if we added an abstract method of some kind to fruit, then apple would need to override it as well. Okay, but how to eat an apple? I don't want to drink my calories. Ooh, I know. Well, actually, okay, I may be on a diet, but we got to do that. All right. That's the name of my younger son's creche, actually. Okay. Orange also extends fruit, so we have to have it how to eat. We can make orange juice. Peel it. All right. Okay, so if we compile it, it should give us no compiler errors, right? Is there a main method? Did I give? Yeah. Now notice that I can create an object array called objects. I can put in there a new tiger, a new chicken, a new apple, right? And then each time through, it'll do some fun stuff. So let's see. Let's see what happens. Okay. For I equals 0 up to length. Okay. Objects of 0. So the very first one is a tiger. Is that an instance of edible? If you need to pause the video, you can, because think about it. Is tiger an instance of edible? Okay. Let's see. If it is, we're going to do something, but it's not. The tiger is not edible. No, okay. I've never eaten a tiger. If you've eaten a tiger, good. I'm proud of you. I don't know. It's not. That would be weird for me. Okay. If objects of I is instance of animal, is tiger an instance of animal? And the answer would be yes. Now, the reason why we have to cast that object to be an animal is because remember that the only thing that when we're running through this, the only thing we know about objects of I, the only thing we know about that is that it's an object. We don't know what kind of object. We just know that it is some child of the object class. And so what that means is that it doesn't automatically have a sound method. So we don't know if there even exists a sound method. So we have to explicitly cast it to be an animal so that we can say, we know you have a sound method. So there you go. All right. So what does the tiger make? Tiger makes the roar sound. Okay. Moving on. Second one, chicken. Is it an edible thing? Yes. So again, we still have to make sure we cast it to an edible thing so that we know that we have access to the how to eat method. Scara. Is it an instance of animal? The answer is yes. All right. Okay. And then our last one, our apple. All right. Is it edible? Yes. Oh, we did make the sound too, yeah. Okay. So we do that. Is it an animal? And the answer is no. Okay. Okay. So that's how we can do the test of the edible interface, of how the interface works. Remember, we have to cast it to it explicitly so that we can know that we have access to that method. Now, we don't have to cast it for other things. So, for example, let's say for each object in there, I wanted to say system.out.println. Okay. Okay, so no compiler error. I didn't cast it to anything. Okay. But when I go to print that toString method, I did not override the object toString method. So therefore, Tiger got that. Right. Chicken is going to get something similar. Right. Chicken gives me this. Apple tells me this. Now this is the native toString method of the object class. So, okay, let's see. So let's try that. Let's debug. Step through and see what happens. So notice that the tiger says I am an animal. That's because that's the toString method for the animal class. Chicken says I'm an animal because that's the toString method of the animal class. Apple says the same thing as before because we didn't override the toString method of the fruit class or the apple class. Okay. All right. So let's try one more thing. What if we tried to override the toString method here? ToString, and what's the toString for edible? I am edible. Oh, wait a second. Oh, interface abstract methods cannot have a body. Do you know why this is? I'm going to give the answer in just a moment, so pause the video if you want to think about it for yourself for a few minutes. Okay. But why? An abstract method is going to have a body. Answer coming in 3, 2, 1. So remember what we said was interfaces could only have abstract methods. This is not an abstract method. Okay, so I can't override a method in the interface. Okay, yeah, which is very helpful. Remember, interfaces can only have abstract methods and public static final constants. Okay, so let's take that out, build it back. Okay, so there's that. There was one other thing I wanted to do. Not the how to eat, not the sound. Fruit. What was it? It was one of the things I came up with as an idea of something I wanted to do. I can't remember what it was. I'm sure I'll come up with it as soon as I stop this recording. One thing I do want to point out is, again, if we take this off, oh, I know what I wanted to do. So if I take this and put it as a lowercase s and compile it, I don't get an error, right? I don't get any error, right? But watch what's going to happen when I go to run this. Is I might expect here, let me pull this up. Okay, so the tiger roared, but when I do the toString method here, wait, that's not the toString method that I wrote, is it? Look, I said toString, I'm an animal, but it doesn't do that. What's going on? Capital S here, lowercase s here. Okay. So when this goes to access the toString method, it's going to initially look in the animal class. Well, I guess the object is a tiger, so it's going to look in the tiger class and not find it. It's going to look into the animal class, and you might think that it should find it here, but that's not right. Okay. This is not the same toString method, so it won't find it in the animal class. What's animal's parent? Object. It will look in the object class and it will see it right there, okay, in the object class. All right. One more thing to do. Chicken is Gara and chicken there. Moshikari. There. So you might think, okay, well, I'll just do this then. I'll just do lowercase s, and I'll compile it. And what's going to happen? Compiler error. Big compiler error because what? Object class doesn't have a toString method with a lowercase s. The only thing the compiler knows is that this is some type of object, and it only has the uppercase s there. All right. So you might say, okay, well, here's what I'm going to do. I'm going to cast it to an animal. Okay. I'm going to cast it to an animal so that I have access to that lowercase s toString method. That'll solve it. Okay. Good. Now I want you guys to take it. I want you to pause the video here to really think about this. Think about what's going to happen here and why. I said I'm going to cast this to be an animal to get the toString method. Okay. But that object array isn't just animals, is it? It's also an apple is in there, a fruit. But the fruit class, where are you? There. The fruit class doesn't have the lowercase s method, does it? Nope. Fruit class doesn't have that. So should this generate a compiler error because you can't do that. You can't take a fruit and put it into an animal. So what's going to happen? Think about it. All right. So now I'm going to compile it, and I'm sure you're probably thinking you'll get a compiler error. And you do. All right. Oh, I know what. Wait, hold on. Because I forgot the parentheses. I was not expecting a compiler error. You'll see. I get no compiler error. But wait a second. This, I can't put that into an animal. It's a fruit. You cannot put a fruit into an animal. Well, I mean, I guess an animal could eat a fruit, but you can't put an animal into a fruit into an animal. How does this happen? It's crazy. The compiler does not know that what's in here cannot go into here. It doesn't know that. That is a runtime thing. Because as far as the compiler is concerned, that and that are the same thing. Okay. The only thing it knows is that it created an array of objects and it has some objects that are in it. And here we're trying to take some of those objects and put them into this animal class and say that it is an animal. The compiler doesn't know that. This is a runtime. This is going to be a runtime error. Okay. And you'll see here as we step through. Notice. Tiger roars, I'm an animal. Chicken is gargaduck, and I'm an animal. Elmo shekeri. And when we try to run this, we will get a runtime error because apple cannot be cast to a class animal. Okay, the compiler doesn't know that, but the runtime does. The runtime does. That can't happen. Okay. So this is a big reason for why the best solution for this is to leave this like that. Okay. The best solution. Let's take that there. And if we want to override the toString method, let me leave it lowercase. Sure. Yeah. Is to put that at override compiler directive on there. Because the reason why we do that is, again, when we go to compile it, the compiler will tell us, hey, that's not right. There's no method in a superclass. There's no method in a parent that's called this. And then we can say, oh yeah. That should be a capital S. So that when we compile it, now that's right. Okay. All right. So let's see. How much time was that? Okay. All right. So that pretty much completes the discussion on interfaces and abstract classes. All right. There is also this, we talked about this comparable. By implementing the comparable class, right, we can take these different strings and compare them. We can sort because these things are comparable. right? All right. So we can sort an array because string objects are comparable because they implement the comparable class. Same thing with the big integer class. It's a comparable class, and so it can also sort as well. And so if we put anything into a comparable, implement the comparable interface, then we can sort them, we can arrange them, we can check if one is bigger or smaller than another and stuff like that. Okay, or should be considered greater than. All right. So all these are examples that are available on the class materials folder. Go ahead and take a look at those. Yeah, so like I said, that completes the discussion on abstract classes and interfaces. I'll try to, when I can, make those edits to the assignment description, but you should be able to have what you need to be able to start working on the assignment. And I'll see everyone on, let's see, this class will meet on the 8th. So then we'll have a live lecture again on the 15th. All right. So have a good weekend, and all right, see you then.